Hello, everybody. Welcome to Makercast. We are back after a bit of a winter slumber, let's say. And today we have. I'm Radom Dopieralski. I'm the host today, also known as the Shipu. And we have two more guests that I will let them introduce themselves. So, Clem, go ahead. Oh,
Hello. Yeah.
go ahead.
Hello, I'm Clem, known on the internet as MayaMakes. I'm the guy who makes videos for Element 14, among others. And today I have some Wi Fi related projects for you. And we also have another guest, Braden.
Hey, good day. Wi-Fi is always great. Braden Lane. I do a number of projects. Mostly, my big one is a challenge coin and challenge puzzles. But wanted to introduce AVR 8-bit coding, and so I've created this new one, which is the AC1, and I'll be talking about that.
Okay, and I mostly do game consoles, robots, and keyboards recently. So I guess you might have seen any of those. Okay, so Brandon, I'm sorry.
That's all right.
Somehow I always insert that N into the middle of your name mentally. Brandon, do you want to go first?
Yeah, go right ahead. So
I'm going.
I've been using 8-bit. There we go. Thank you. I've been using 8-bit microcontrollers for a few years now, and I really think that they kind of get the short end now that we've got these incredible 32-bit chips like the STM32 and the SAMD 21 and 51. But the 8-bit chips that Microchip has been producing for the past few years and has introduced with the AVR series are just incredible powerhouses for very, very little money. And the great thing about them is they need almost zero, extra components to make them work. And I've been using them for a lot, and I wanted to introduce some group of people that I've been talking to what these chips can do. And so I said, well, let me put together a little class. And so I started actually writing out a coding class for these AVR chips. And what we see right here in the middle of my screen is a mock-up of the AC1, which stands for AVR Coding Kit. And it consists of 42 LEDs that are Charlie plexed. So the class will cover how to do timers and Charlie plexing. It's got a piezo buzzer on it. It's got a couple of buttons. And one of the things that I love about these new AVR chips is you don't need some complex programmer to use them. So I'm going to switch to a live camera for a second. So that actually is a running AC1, and what's important to realize is how small it is. It's 50 millimeters by 50 millimeters, so it's just 2 inches. And to program it, all you need is a little UART USB adapter. That's it. No special programmer needed. Built onto the AC1 is a little resistor and a switch that will take the UART adapter, this little guy right here, and switch it between being a serial interface, like you might be familiar with for like an Arduino, and being a programmer. And then everything else is software. You don't need to have any extra hardware to do that. And so you can see here, it's got a couple of buttons. It's got a battery holder. So once you've got it programmed, you can actually just disconnect this thing and take it with you. It's tiny, it's small, and it can play a buzzer. I don't know if it's going to be audible, but the demo that it comes with plays a little bit of a sound, some music, and the heartbeat goes to it. And so the hardware I designed specifically to support the class. And the class is completely open source and free for everybody. You can download it. You don't even need the hardware. You could probably adapt it to almost any hardware. So this is everything that's covered in the class using that one piece of hardware. So simple blink. Of course, everybody has to do blink. And what is astounding is if you are writing true AVR code, so that's I've got a quick example here. So we look at this little one right here. I realize the text is probably a bit small, but like to turn an LED on, you just set a port register with a value. And so blink in this example is 192 bytes. It's absolutely tiny. And the Charlie plexing of the LEDs is like 700 bytes. And that includes a display buffer. So that's really what the AC1 was designed for. The AC1 was designed so that I could introduce people to this chip and what it can do, and bring it back up here live again, and give them enough hardware that they can do all the functionality they want for the class. It's 6 lessons, completely open source. Once I've gotten a group of students through it once, I'll create recordings and videos of it so that each lesson, which has got a lot of detail, it's all written out. So I'll just quickly show you an example of a lesson here. So lesson 1 is blink an LED with a button. And so all you really need at that point to blink an LED with a button. So it walks you through the process, introduces how the memory of the chip works, gets into the basics of ports and pins and how they work. And then it literally will step you through each bit of code that you need to write the first lesson, and then it moves on to the next lesson. Each one builds on the next. So lesson 1 focuses on blink an LED with a button. Lesson 2 takes that and says blink an LED with a timer. Lesson 3 says use all the LEDs using Charlie plexing and a timer. So each one builds on the next, and they're all very easy to digest, and opens up, I think, a lot of people to these chips and what they can do. So that was what the AC1 was originally designed for. And of course, I've already started thinking about what the AC2 might look like. But again, to me, the biggest thing about this is these chips program with nothing more than a UART adapter and a resistor. It's all it takes to program these chips now, which is fantastic.
I assume the programming is then UPDI, because like serial and a resistor tells me something. I think that's a UPDI flashable chip, isn't it?
Exactly. That's all it takes. So Microchip has actually published a simple Python program. So you don't even need to have like AVR dude and installs and stacks and all that junk. It's literally a Python program, and UDPI can program with nothing but RX, TX, and a resistor. So a little UART adapter and a resistor across it, and you've got a programmer. So it really lowers the cost of being able to use these boards for stuff in these chips. Mm-hmm. And as you can see, you don't have to have everything on that board is specifically designed for the class as far as functionality. There's not like a lot of extra, other than that one resistor, there's nothing on the board to support the chip. The chip runs all by itself. It doesn't need anything except power. And that's really kind of fun. I did do something interesting on the design of the board. So instead of labeling it button 1 and button 2 and buzzer and stuff, everything on the board is labeled with the actual port and pin identifiers that you're going to use when you're coding it. So, that top button right next to it, the label is PB5, port B, pin 5. And the same for the buzzer and the other one. So it really ties in easily for, people who are starting to figure out how to do AVR coding. Maybe they've got some experience in C programming, but never with a microcontroller. The board really dovetails right into the course material, and that's why I designed it the way I did.
This means you don't have any abstraction layer on top of the board. You're basically doing bare metal programming, and you're naming all the pins like they are actually on the bare chip, not like an Arduino where it's D2 or A5 or something like that.
Exactly. The goal of the class is to show that these chips can be programmed very easily now. Microchip has done a lot of work with the way the chip is architected. So they've even simplified things. Like it used to be that if you looked at bare metal coding of a microchip, you'd see an awful lot of bit manipulation where you'd see bit shifting and ors and ands and knots and stuff like that. they've even simplified a lot of that for the basics because they've introduced specialized registers directly to the pins so that now you've got outset and out clear, right? So you want to set something as output, you say outset and you give it a pin number. You want to make it input, you do out clear and a pin number. You want to make it high, it's or actually no, sorry, out is for high and low, dir set and dir clear. So they've created these registers so that it reduces a lot of the old gorpy, bit manipulation you used to see. But again, you're right. You're not dealing with abstraction layers and anything else. The course and the chip is really designed to say it's not difficult to code directly to a microcontroller, and it's incredibly fast.
And
so
then it's
we have a question
oh yeah,
from Atomic 14. Wonder what the battery life is.
I don't know. I haven't done a battery test on this, but I use one of the big brothers on this chip and running all the LEDs and the buzzers and UART and actually 2 UARTs on it. When I do the e-challenge coin, there's 2 different UARTs running. One for interacting with it to do the story challenge, and the other one is an infrared transceiver that is used for communicating and doing handshaking between challenge coins. And when it's running, it's using between 4 and 6 milliamps. So continuous running on a CR2032, you're looking at 40 hours of continuous use. And when it goes to sleep, it's about 400 nanoamps. So we're well below 1 microamp during sleep mode.
AVRs were always pretty.
Yeah, and I love them for that because so like the challenge coin, which is what got me into AVR programming. I have one on my desk from 2 years ago. It still has the original battery in it. And every once in a while, I pick it up and play with it, and then I let it go back to sleep.
How hard is it to get those to sleep? Because on some microcontrollers, it's like with libraries and stuff, you can just type sleep, but on others, you have to activate that register, then the other one, and set the wake up sequence and stuff. How is it with those chips?
So the AVR, it's just like you described. You've got to make sure that the registers are in the right state, and you set a few flags in here or there. With the AVR, it's gotten so that it's easier. The code looks a little more user friendly, I would say. But there are some hiccups. And actually, when I start to write AVR coding 102, we'll get into power management, and we'll talk about the fact that if you don't have your registers in the right state, then when it goes to sleep, they're still using up some power, and so you got to set those up. And one of the fun things about the class is we're going to get into using like an oscilloscope for doing debugging. It's not required, but it's kind of a fun thing to be able to go through and like in this case, it's showing when the LEDs are being refreshed. And we'll get into for the Charlie plexing. I'm just going to quickly bring up I'm going to add the AC1 back in the picture because it's blinking right there. So one of the questions that I already know the students are going to be asking is, well, okay, if we're updating all these LEDs during an interrupt handler, how long is it taking? And the answer they're going to learn in the class is that it uses about 24 microseconds to update the LEDs. Every 2 milliseconds it does an update, and it takes, like I said, 24 to 27 microseconds of time. So the LEDs aren't taking any time at all relative to everything else you can do while the chip is sitting there getting busy.
That was also a nice thing in AVRs that each assembly instruction was exactly the same. Well, most of them.
Yeah, most
was exactly the same time. There are some that are double or triple. But
yeah.
That means if you know it for one chip, you basically can program all the AVRs.
Most of the AVRs are now within a family are very, very similar. There's tiny little differences, but you can be programming a 50-cent AVR 412, for instance, to do stuff. And then if you need more memory, you can jump up and the code just recompiles all the way up to the newest ones, which are the AVR64DD chips. And those are wonderful chips, but there's not a lot of code available for them right now. I had to write my own low-level libraries to do my challenge code. I'm using that chip on a project this year.
There is a question from Devon's workshop. What is Charlie Plexing? Style of LED? And after it has some Charlie Plex stuff, I just associate it with those tiny LEDs.
The question is, what is Charlie? Okay, so actually, that's one of the questions that comes up. I know in the class, and I tried to do a fairly good job at explaining what Charlie Plexing is, and then I found out that Brian Locke did a much better job than I ever will, and actually created an entire video on it. So, I originally only thought Charlie Plexing would be used for discrete LEDs, but then I started using them with RGB LEDs as well. Charlie Plexing is a very simple idea that an LED will flow and light when it's powered one way, and it will not flow and light when it's powered the other way, which means you can take two pins and connect two LEDs in, one in each direction. And depending on which one you set as power and which one you set as ground, one or the other LED will light. Well, it turns out that with Charlie Plexing, you end up with an n times n minus 1. So for the AC1, I use 7 pins. 6 times 7, or 7 times 7 minus 1, 6, is 42. So those 7 pins give me 42 LEDs. And so that's what I'm able to do. And then you have the option, you can, in this case, for the class, I treat them all as just on or off. So my timer only ever needs to update the 42 LEDs on or off. But through persistence of vision and PWM, you could even do brightness with Charlie Plexing LEDs. So, and that's the other thing about the course. The whole course is open source. It's free. It's MIT licensed. People can, copy it, edit it, change it, do what they want to it. And
do you have a URL?
There is a URL. And actually, I've got to be honest, I've been tweeting and posting and stuff the heck out of this so that the search engines will find it. So
I can post it if you paste it in the private chat. I can post it in the chat so that people can.
Actually, I think at this point in most search engines, if you simply search for AVR coding 101 as all one word, you will find the course material.
Yeah, but in 4 years from now, when people are watching this on YouTube recorded,
we should post that. Yeah.
Oh no, we'll post it. It's right there.
My biggest question with that, because I'm really interested in the course, because I want to get more into bare metal on AVRs and on microcontrollers in general, because I always use some sort of expression, it's Arduino or MicroPython or something like that. But I want to get closer to the things so I'm not as restricted on the choice of components. So I can just take an AVR and run with it. What is the tool chain that you use there? Do you need a specific IDE, compiler, or can I just write it in Nano and do CMake and stuff? How does that work for this course?
That's a great question. And actually, there is a prereqs page within the documentation. So the syllabus and the prereqs, and then all 6 lessons. To simplify it as much as possible for the students and to be as cross-platform as I possibly could, the course uses Platform IO with VS Code. And the reason for that is because the minute you tell Platform IO that you're using, in this case, an ATtiny 1616, it knows to go get GCC for AVR. And so it will bring in the tool chain for you. But to your question, there are no libraries being used. The only thing that gets used here are the header files from Microchip. that are provided with the GCC AVR toolchain.
But that means if I would install GCC AVR on my
You'll have all
computer,
that.
then I
You'll
just
have all that. Yeah,
use
you'll have
any
all that.
editor, write the
Yep.
code, do CMake with GCC,
And then use
flash that with the Python script.
Yep, exactly. You don't have to have Platform IO or VS Code. You could use anything you want. Like I said, that the two sort of big pieces that you're pulling in are GCC AVR, which is that tool chain. Basically, it brings in the header files for you and everything else. And then the Python program that's used, and it's also completely documented within the prereqs page of the documentation from the URL that we just posted. It's called PyMCU Prog. So PyMCU Prog is the Python program. And it can do more than just Flash, right? It can manipulate the EEPROM. It can read the fuses. It can pull the signature byte off. And actually lesson 6 in the class actually does that. We get to play around with like, what's the unique serial number on your AVR chip and that kind of question. And
that's really interesting.
And the class on UART serial communication with the chip is broken into 2 parts. One is what's the most basic? I just want to be able to print hello world and get debug statements off, which is what most people use serial communication on AVR chips for anyways. And that's, I think that's 259 bytes. Hello world in 259 bytes. And then there's the full bidirectional interrupt-driven UART capability also taught in the class for those who need it.
Can you show us the back of the board?
Oh, yeah, sorry. The back of the board's actually pretty funny. So I think this... Let me unplug this thing for a second because I'm going to set one board right on top of the other board. I think this will work. The lighting might be a little bit off. The back of the board is actually lesson 1. So all the code from lesson 1 is on the back of the board.
So
That's
where's
handy.
the buzzer? Because I couldn't see it on the front.
The question was... Repeat the question again?
Where is the buzzer, the speaker?
That right there?
Oh, I thought this is an SD card socket. Okay.
No, that's right. And actually, I worked very, very hard. There are very few buzzers that are loud enough that will work off of a 3-volt coin cell battery and be audible to most people. I've gone through dozens of trial and error before I finally settled on this one. It's bigger than I would like, but it's the only one that I can find that you can actually hear when it's playing on a coin cell.
They also have their favorite frequency.
Yes, they do have. They will peak a little bit, but this one's pretty good. I mean, it's for playing square wave tones. It can do it can play music, and the what I'd classify as sort of the final exam demo brings everything from the class together. So you can see it does a little heartbeat animation, which is what it's doing now. When you press one of the buttons, it plays a song and the heartbeat will beat to the tune of the music. And off the UART, it will actually output the lyrics of the song at the same time in synchronization with the music. So the students get to do the whole thing. It's kind of fun.
Okay, very nice. So when are you starting with this?
I've got a group of students that I'm testing with starting tomorrow night.
Nice.
And
good luck.
Yeah, thank you. And based on their feedback, we're going to update the documentation, add some, if they've got things that are troubling, then I'll go and rewrite those and work them up. And then I will record probably 30-minute videos, 20 to 30-minute videos, one each for each of the lessons in the class. And then all that will be, all that will be open sourced and available. So.
Okay, that's really great.
And then I'll crank out a bunch of boards and put them up on Tindy.
Of course.
Well, I mean, it's you can use any hardware you want, but the course is
it's just convenient. It's just
really convenient because not only do I, provide the board, but it also comes with the programmer. So literally the only thing you need to get is a USB-C cable and you're done. You're ready.
And you are not wondering if it's something you connected wrong or, Or
That's
is
true
it-
too. Yeah, because I all the boards get tested and they go out with the demo built into them, so it's good.
Yeah.
So
Okay.
yeah, I'm really looking forward to it. It's been a bit of a project, but I love the chips, and I think they're really kind of useful for a lot of low end buttons and badges and even sensors. The in the 102 class that I'm already starting to put together. One of the things you'll be doing is you'll actually create an I squared C client, or I guess they used to call them slave. I can't think of what the right term now is for master slave on.
Peripheral, I think.
But so it will be listening for I2C, and then you could use it in conjunction with a Raspberry Pi or an ESP32 or else. So the 102 class will teach you how to build I squared C enabled sensors as well, which I think is where the real sweet spot for these chips are for people who want to use them in robots. I already have one example I want to try to do, which is to I saw it a long time ago. It's an octo. It's 8 sound transducers in a circle, and a microcontroller in the middle that talks I squared C, and you basically can get a 360 degree distance image each time you interrogate it. So it's like a big circle, or circular proximity detector.
Yeah, basically a sonar.
Yeah, but with you don't have to like spin it around. It'll just it does it all in one shot.
Yeah, with ultrasound spinning wouldn't work that well, I suppose. With light, it's better.
There you go. So anyway,
yeah, thank you very
thank
much.
you. Thank you.
Super. We are looking forward to it and to see how that goes. Clem, you go next.
Okay, so I've just tried to get my project working for a demo, but I think I know what the issue is. So, okay, basically my theme for the last few projects was Wi-Fi modules in different capacities, like doing different things with them. Because basically to preface it, component shortage, we all know you can't get the chips you actually want to use, so you have to use whatever you have. And I happen to have a lot of Wi-Fi modules in stock because they were cheap. I especially bought a lot of ESP32S2s because they were they appealed to me because I didn't have to use a USB to serial converter because they have native USB. And that means if I just put a USB port on a board, then I can flash them directly with the Arduino IDE, and I don't have to think about some special interface and some chip in between that doesn't work right. Like here's a CP2102. I'm pretty sure everybody's familiar with that one. And I just wanted to omit these. So I started using them more and more. And when you can't get any other chips, you use them for everything, no matter if it needs Wi-Fi or Bluetooth or whatever. So yeah, and then I did like a few projects that you can see on Element 14. In like every second project or so, I've used an ESP in some way. Yeah. And of course, everybody that has done stuff with ESP32s has thought about deep sleep stuff, saving power, basically. So there is this one thing that really grinds my gears. You have to have some sort of wake-up mechanism to get a microcontroller that is sleeping back to its working state when you want to make it do something. And the usual way to do that is either have it wake up with an external interrupt or have it wake up with a periodic wake command. So every X seconds or every X minutes or hours, it just wakes up, connects to the network, and then gives a message. So if you make like an IoT device, let's say you have a security sensor that checks if a door is open or something, then the only way to know if the door is open is have that wake up every X amount of time, and then connect to it, to the network, and then tell the thing on the other end of the network what its current state is. And you can make it trigger with an external interrupt. For example, like on this board, I've used a little read switch here. Read switch is basically just two contacts that get in contact when a magnet is close, so they pull it together, and then it's the same as if you have pressed a button. And that wakes up the microcontroller, and then it would connect and send the message. So it would only do that when the thing is activated. And the other thing is the quirk with ESP32s in particular is that they can't sleep forever. Like you have to set some sort of periodic wake. I'm not really knowledgeable in that regard why that is. I think it has something to do with a buffer overflow, like numbers add up and then it overflows. So it has to wake up at least once in X amount of time to avoid that and prevent the chip from locking up or from resetting. So basically you have a periodic wake, and then in addition to that, you use a pin to wake up the chip. And I thought that's kind of against the idea of low power IoT stuff on the edge. It's nice that they wake up and inform me, but what I really would like to be able to is just ask it. Like whenever I want to know the state of a sensor or the state of a pin, or just get some data from the chip and know how its battery is going. I don't want it to tell me when the battery is low. That's already too late. I would like to just ask it, and then it should give that back to me. But I can't wake it up without having any sort of interaction or having that timer do that for me. So I want it to be at sleep forever, so it doesn't waste any power. But I also want to be able to just ask it. And then I've got like some info from Renesas/Dialog Semiconductor, and they make Wi-Fi modules. And on here, like there are two on here. This one is an ESP32S2 Mini, and this one is a DA16200. That's the one by Renesas. And they claim that it uses the lowest amount of power for Wi-Fi modules with sleep. And if you look at the data sheet, it says it uses 3.5 microamps in that sleep, and you can use all the different comparisons with an ESP32, and you basically see it's almost the same. But the big difference is that it has a sleep mode. It's called sleep mode 3. Like there's one is basically complete hibernation. It's like pulling the reset pin low. Then there's, or high in that case. Then reset pin low is complete hibernation. Like there's about nothing as power has been drawn. But if you pull that high again, then it instantly wakes up and it connects back. Then there's sleep mode 2, which is basically waiting for the RTC, and for the RTC is the periodic wake, or for a pin. And there's sleep mode 3, and that's the interesting one. That is actually letting it stay connected while it sleeps. So the network connection is not broken up. Usually, when you put something to sleep, you cut off network, then it goes to sleep, it wakes up, reestablishes network, and sends a message. And that stays connected, so I can actually find the chip still on my network while it's sleeping. And I can send to it. And I've done it in the video. I wanted to show that, but something has changed in my network config, and I can't reach it now. Don't know why. It's always giving me back, like I can talk to the chips, but it's always giving me back error 4, which should mean that it can't connect to the NTP server. So I think that the passwords or stuff from this board to my router, something has changed there. So I haven't used that board for like 2 months or so. It stores all the credentials in an EEPROM on there. And so I don't have to like retell it all the credentials with the microcontroller anymore. So it just remembers, reconnects, and does the thing. And when it stays connected, it doesn't have to enter them again. And I can send a UDP message from my PC to that board and wake it up that way. And the script in there on the ESP32, like this is just on there because I had it. You can use a tiny AVR for that one, for that purpose. Basically, it just speaks via UART connection to the Wi-Fi module. And the UART connection was supposed to be like in between those two chips, right in here. But that didn't work because it has two UART ports. One is only for debug and the other one is for actual serial communication with AT commands. And the port that I used is only for debug, so I had to put this baud on here, do a little operation, which also took up the only pin that I had accessible for the wake up via a pin. So that basically works whenever the modules are just not talking to each other. When they're talking, then this disturbs communication, but in theory it's working. And these two chips just talk UART, just talk AT plus some commands, and that does all the settings. And whenever the Wi-Fi module, the DA16200, wakes up, it wakes up the other microcontroller, then that one has a message on it and will respond with that message. And because it's waking the chip up first, and then it stays awake until the other chip is done with whatever it's doing, it has to send a command again to say, I'm finished, you can go back to sleep now. That means if I basically send not just one, but spam the UDP commands, because UDP commands can get lost on the network, so I just spam it until I get a reaction. And so the first one is basically, hello, wake up. The second one, the payload that UDP command has is basically asking that chip for sensor data or battery status or whatever. And then it responds, sends that to the Wi-Fi module and gives it back to your network. And that way you can ask your device all the time whatever you want. And that was pretty cool. I also made that work on 2 coin cells, and 2 just for one reason. The ESP32 wants stable 3.3 volts, and the DA16200 works on 3 volts. So if I would use a different chip, like a tiny 80 tiny or something, I could run that all off of one simple button cell. But in that case, I just had to use 2 to make sure that the voltage levels would be correct. That was quite good. I was pretty proud of that. In the video, it's pretty funny. It's now on YouTube and element14.com. And we also have the code and CAD and stuff. It's all open source. You can check that out and look at it. The only tricky thing, that's the reason I can't directly demonstrate it, is configuring the Wi-Fi module first, which was a big pain in the ass because I didn't understand how the serial ports correctly work on there. And I got the dev kit, the official one for that. And that made me understand the commands. But it has some ambiguous hardware markings with the RX and TX pins. There are some are called RX and TX, and then other ones are not, but they are actually just the other serial port. Yeah, documentation is not the best in the world. But I can highly recommend, if you're getting started with these modules, get some dev kit of some sort. Maybe the original one, maybe I make one. But it's a really interesting module for these applications if you want to wake something up without having to touch it in any form. The only thing that really holds me back from doing really a lot with that is A, price of the module, and B, there is no Arduino integration besides a library that does not support these special sleep modes for now. And the library only works on AVR. which I think is really dumb because it's just AT UART commands. Yeah. If that the chip has about, I think it costs about 5 to 7 euros, depending on where you get it. So it's for a Wi-Fi module normal, but it's not as super cheap as an ESP32, sadly. But I think if there would be, like, it's directly programmable with an SDK that Renesas has, but I hate proprietary SDKs and frameworks and stuff they give you. And it's always only for Windows, which, who uses that? But if someone would make an Arduino core for that module, I think it could be really popular. But sadly, it's not yet done, and I can't do it. I'm not smart enough for that. Yeah, so that was my project, basically.
Nice. It's a bit funny to use a Wi-Fi enabled board with a Wi-Fi module, but I guess that's just convenience. I wonder if you could have them use the same antenna.
Maybe if you have some sort of antenna switcher, but I think like the switching circuit for an impedance matched antenna on there might be more expensive than the modules.
Especially if you use a PCB antenna. The antenna is for free.
This one has the D816-100 has a chip antenna on there, and because I don't really need it, I use the non-antenna version of the ESP32 on there.
Yeah.
So yeah, makes sense. Yeah.
So
and
you are using that
I've made a footprint. It's the default firmware that's on there. I've not changed anything to that. So that's the AT firmware is what comes on there. It just speaks normal AT commands, because I think the point that the manufacturer has with these modules is that you can use, when you have legacy applications, you just put that module instead of the module that you used before, and it just works. It uses the same standard AT command set, but the sleep stuff, that's a bit different. And I couldn't, like, in theory, according to the documentation, these wake-ups should work with any protocol. I could only make it work with UDP so far. But I don't think it has really something to do with issuing the right commands on the chip. I think it's about my network not wanting to have the communications all the time with TCP. Or basically it thinks that the connection has timed out or something. That's at least my interpretation of what is happening.
TCP has a session.
Yeah.
I think it's the session has expired and then it just stops talking. But on UDP, it doesn't care. So.
Yeah, the low power part is what I'm really interested in, because I do a lot of the low power stuff. So it'd be interesting to figure out if it's possible to, like you said, swap out the ESP32 that you're using it to communicate and drop in a really low power AVR. And then you've got an AVR plus that one chip. And I think that could be really kind of a cool combo.
Yeah, it's basically like this is something that the people in the video, I've said it 5 times in the video.
Yeah.
And I expected my editor to just remove 4 of those times. I just leave it in there where you think it's appropriate. But I left them in all there, and still people were commenting, why? What's the ESP32 doing with the Wi-Fi on there? And do you need it? No, I said it multiple times. It's just any microcontroller. I couldn't get an 80 mega. I'm not ripping apart an Arduino for that. Okay, so it's just what I had. I just need any microcontroller, and I basically use this as a UART bridge.
Exactly. And that's what I was thinking.
It's cheaper than a CP2102. Because I bought like half a reel of those, and so that's like €1 for that chip. Yeah. And the CP2102 was the cheapest one, like €2 or up to 5. So it's cheaper for me to use that as a UART bridge and like waste all its power. But it's And now I know it's if you want to get the point across, you should use the right part or just put a piece of tape on over there so people don't see it. But yeah, it's the
exactly.
point is to use this module with the bare bones minimal microcontroller. It just has to speak UART.
Yeah,
that's it.
Yeah, and with the Act One, it was
yeah.
I went through the same thing. I originally had been looking at using CP2102 or CP2104 based boards, and it was ridiculous. And then I found a supplier that would provide pre-built CH340s with a USB-C connector, which everybody's now telling me I have to use. And the whole board with the headers and everything else was less than the chip of a CP2102.
Yeah. I'm experimenting currently with making my own Linux SBC, and it looks like it's cheaper for me to buy the original dev kits for the processor I want to use, rip it off there, than buy the processor. It's ridiculous.
I wanted to prototype a SAMD21 project for next year that I wanted to start prototyping this year, and my solution was to go buy a board and unsolder the chip.
Apparently, SAMD21 was scheduled like March this year. So fingers crossed.
Actually, I have stock. I received 500 chips.
I bought the last 50 from Mauser.
Yeah, I snuck in an order when I saw that there was a likelihood that a vendor or one of the distributors was going to have them, and so I put in an order for 500, not thinking I was going to get them. And the first week in January, I got notification they were shipping. So,
Clem, Dave Odessa is asking if you are using DHCP or is it static IP?
It's static IP, but it can use DHCP. Apparently, but I'm using static IP because my network here is a bit complicated, and I use these old Netgear Wi-Fi sticks to circumvent that when I'm prototyping Wi-Fi stuff. So basically, my main computer is like walled off from the rest of the network, and when I want to like communicate with something like this, I use such a stick, which is that's like a pretty special one. That's a really old Netgear stick, and I have like 50 of those. Just bought them in bulk because they use no drivers and work on any Linux PC. Like out of the box, just plug them in and they work. With and also they like to talk to microcontrollers, which is not a given with a lot of sticks. And then that goes to a router that is only there for this kind of stuff. And the problem that I have is if I use dynamic IPs, then sometimes that goes out of sync, and basically I think they are all on the same network, but they're not. So maybe sometimes they reconnect, and then because some numbers line up, the number 103 that gets given out multiple times, and then nothing works. So for these type of projects, I always use static IPs because I know the IP address, and when I send something to that address and it doesn't get there, I at least know it's not because of the IP address. I know there's a different issue, and that's something that I had with like a lot of sticks in the past, or when I used the laptop for that with the integral Wi-Fi module. That was always a problem. That's why I use these old dedicated sticks. And there's one thing that sets these DA16200s pretty far apart from the other ones. It's not so severe now, but I think you all have encountered that when you buy a Wi-Fi module, then it's always made for use with microcontrollers or for embedded stuff, but it's not used as a stick like that. So you can just connect it via USB or something and talk to use it as a Wi-Fi adapter for your computer. And that one is actually like the DA16200 is made for that purpose, basically. So there is a Linux kernel driver for that one. And the dev kit is basically a PCI Express card. You can plug that in a computer and use it like a Wi-Fi dongle on your computer, which means that I'd like to. I thought about using that in conjunction with an SBC, like put it directly on the board to use that as the Wi-Fi bridge for that. And then at Electronica, I saw that there is a new ARM board by a Bulgarian manufacturer that has the exact same module on there. So I'm not the only one thinking about that. And now for the ESP32 family, for most of the chips, there is a firmware, an open source one made by someone, sorry, I can't remember the name, that also allows that. But you have to flash that firmware first. And these should work out of the box without reflashing the firmware. So just you install something on the computer, and then they should work as a Wi-Fi bridge, which makes it also interesting. The only thing that I really want to have is like an Arduino integration or something. I don't want to use proprietary SDKs. That really grinds my gears. Yeah. Sorry for the rant. But if there's an awesome chip and I want to use it the way I want to use it.
And that's the way it should be used.
Yeah, we all need an intern that will implement the boring stuff for us.
I read a lot of boring low-level code because I don't use Arduino libraries for anything anymore.
Yeah, I should learn that, but I'm like I have zero formal education with that.
Things that you also have to learn.
I think I should learn just bare C on an MCU, just CMake and flash it with that Python script.
I feel there is an AVR one-on-one lesson.
Yeah, there is this course. Yeah, I should really take that one.
Actually, yeah. I mean, the thing that always amazes me, and I think it's going to blow away the students when I work through the first group of people with it, is if you don't use libraries, it's not that complex to write directly to the chip. Like I said, Microchip has done an extraordinary job at improving the mechanism by which you code bare metal. But more importantly, just how small the code is and how fast it is. Like I said, the hello world printing out text messages over UART at, 115.2, and the whole program is 259 bytes.
That's one of the things. Like if let's say you build any project, and usually the thing you run it on is complete overkill for what you're doing. Let's be real. If you're using an ESP32 for like typical hobby projects, you could run so much more on that. You don't need that power. Any ADTiny would have enough, or it's not even about the pin count sometimes. But the trouble is when you realize that, I could get away with a 50-cent ADTiny.
Yep.
And the moment you try to translate that project, first hurdle is there is no Arduino core for that one. Okay, you can, like, maybe you find someone who did one. Okay, then that's the next thing. Maybe you found one, like there's Tiny Mega Core and like a lot of projects. And then you try to port over your Arduino project. And guess what? It's too big for the chip. But it doesn't do much. It's just the libraries, all the stuff that you have to put in there because you reference it once that clogs up the chip, and you can't really use the tiny chip for the projects that would completely fine run on them just because all this overhead.
Yeah, no.
And at the same time, people are complaining about the overhead and discouraging beginners from using the chips.
Yeah, it's
or using easy frameworks.
Yeah,
which I find stupid.
Yeah, I'm looking forward to getting the feedback from the students as far as is it approachable to do bare metal programming, or is it just too weird? And we'll find out over the next few weeks. I've got 9 students, and they're all pretty excited about it. They range from IT people, security people, one of the people I think is a managing officer in the military. So it's gonna be kind of fun. But you're right, though. I mean, when I did the very first e-challenge coin, at the time it would have been the ATmega 328 PB, and because I wrote that bare metal, I was able to stick a 3,000 word story on the chip, in addition to all the code that had to run all the puzzles and games and stuff. And so, no external memory, nothing else has to be added to it. So there's a lot you can do with the chips, and like you said, with the new AVR set, you can ostensibly learn to write on a 50-cent chip that has 4K, and everything you've learned, it works fine on an unbelievably expensive $1.20 chip that has 64K. That's the other great thing, is the chips are really inexpensive and they don't take a lot. You don't have to have crystals and external memory and everything else to make them work.
Those crystals, that's the next thing. Like, if you are going to use microcontrollers bare as they are,
yeah,
you basically you will have to make a PCB or something.
True.
Yeah. So if the scary, like, I recently finished a project. Well, I finished it. I put it into late beta state. A project that has like 4 microcontrollers and 2 crystals on there. And the most scary thing for me was, while I have put away the development work on that, is because I was very unsure how to correctly connect those crystals and select the capacitors and stuff to make sure they all work correctly. In that case, they have to speak USB together, and if the timing is not right, then everything is garbage. So I was very hesitant about using stuff that needs external crystals. That's why CP2102, super popular, because you don't have to have the. I think the CH340 doesn't need one as well. So
correct.
Yeah, and that makes those a really popular choice. So along the way that they have less complexity in routing requirements, you basically put the chip on the board, power ground, a few caps, and then you have your inputs outputs. That alone makes it much more approachable and like a gateway drug to making your own PCBs and your own designs. And if that's like super complicated, and then you have the big guides with all the routing requirements and best practices and stuff, that's all super scary. And also the code looks scary with all these bit shifting stuff and all these symbols that you never seen in the Arduino IDE. It's not digital, right? It's port B said something. There's a hurdle to that, and I think it's mostly I think it's mostly a mental hurdle. You have to see someone do it and explain it the way you
can
understand
actually do it in Arduino,
Yeah, you can do it. You can run basic bare metal C code in there.
I mean,
you just have to learn
it's a good way to gradually transition to only do write your code in Arduino and only do that one thing you wanted on registers. So then it's less scary and fewer things to break,
But would that also mean that you could, for the AVR coding class, could you just use Arduino as the IDE for that, write the code in there, compile it with that, and then flash it directly?
Actually, the Arduino IDE does have support for PyMCU Prog as a programming interface now. The thing that I would have to figure out is if you can get it to not include any of the other Arduino code. So one of the things that I know that Platform.io is smart enough about this. If you create a project in Platform.io and say that it's going to be Arduino, by default, it creates main with setup and loop, right? Just like an Arduino sketch would be. If you delete those and simply put in your own main, it's smart enough to then get rid of all the overhead of the Arduino code that goes with it. I don't know if the Arduino IDE will do the same thing.
In Arduino, you can it recognizes the extension of the file. So if you have like the I don't know what the Arduino by default has as an extension.
.io.
Right. So if you actually do .c or .cpp, it will compile those as CPP or C.
Okay,
files.
then there you go. Then it will be smart enough to be able to
Right.
take the lesson code and run it in that IDE. I find I quickly moved away from the Arduino IDE back before it had a full IDE environment, and it was a little more work for me. I just found that VS Code allowed me to not only write my C code and my header files, but I could also write my markdown and my documentation and everything else. And so
yeah, I basically used it as a make file because it already installs all the compilers, everything you need. So you write everything in C, but tell people to use Arduino IDE to flash it, and
Yeah,
it works. Then it's easy to explain to them.
Yeah.
how
And
to do
VS
it.
and actually that's where VS Code and Platform IO have gone. You don't see any of the build process. It's all kind of, you can control it if you want, but you don't have to. It's all done for you.
Yeah.
So
Oh, I've seen in the chat we had a question about the weird Wi-Fi sticks that I use. I've just opened one up to show why I use those. That's the actual one that I just plugged in. So basically inside they look like this, and they are really old. That's really old Netgear sticks. And I basically bought the whole stock they had. They work out of the box without installing any drivers on any Linux machine, which is great. And they like to talk to really old or really basic Wi-Fi modules. So they use the really old protocols and not some proprietary handshake stuff. And if you open an up, they have an unpopulated header for an antenna. So that allows you to connect an external antenna to there, which I did in one project on YouTube. And also you can easily remove the shield to get to everything in there if you want to mod them in some way or other. And they are pretty easy to integrate directly into your project because you can just desolder the USB stick, the USB plug here, and then you integrate them right into your product or into your project if you want to give something Wi-Fi, which is pretty nice. And I haven't done it yet, but I've seen some people on the internet who also used some other ports on there, like some debug headers, to connect that directly to microcontrollers. So that's why I use them and keep them around. And they proved very valuable in case I run into Wi-Fi troubles with some projects, because sometimes it's just some stick that doesn't want to communicate, mostly because they complain about some security stuff, or say the network is like the stuff that is sent on there doesn't conform to the protocol or stuff like that, and they don't care. They just work. So that's why. And it's 54 megabytes per second, which is a lot for something like that.
It's proven technology. It may be old, but
it just works. Basically, why change it's old but gold.
There you go. Yeah, there was one thing I wanted to pass along to the people watching, which I think is kind of a fun thing. I learned this from, I think it was a SparkFun video or post they did. When I designed the AC1, it ships with the whole board fully assembled and the little UART USB connector with the headers on it. But to make it easy for people to just unplug the programmer and use it off the battery, I used what we called staggered headers. So I think you can kind of see it. I zoomed in right there real quick. So there's just a little bit of a wiggle between every other pin, and it allows you to push in a standard, 0.1 inch, 2.54 header, full contact on all the pins, but then you can just simply unplug it. It literally is a plug in and plug out kind of thing. and it works great. I mean, I've abused mine. I've been using it for 2 or 3 weeks while I write the course material, and I don't know how many times I've pushed the connector in and pulled it back out again, and it works great.
Yeah,
and
I use
if
the same thing for my
yeah,
projects.
I just
Yeah.
wanted to tell people that you are using that, and also Pamaroni has that on some devices. So that is a proven technique.
Yeah,
I should also start using that. I usually just squeeze them to the side and hope for the best.
Yeah, exactly. So yeah, I just wanted to pass along because I think it's something that if you're designing boards and you want to make it so that you can plug something in and unplug it, but you want to use standard headers so that if somebody wants to make it permanent, they can. The staggered header technique works great.
Yeah. Okay. So thank you, Clem.
Yeah, you're up.
Yeah, my turn. I will take the whole screen now. Oh, I first have to switch. Yeah, it's
There we
on
go.
me. Okay, so this is something I've been working on for a year with brakes because it was super. I always run into problems with this, and then this year I didn't have much energy for projects. So whenever I hit a problem, I would just leave it there for a while and then come back to it a while later. And so basically, the thing is CircuitPython, which is something that I mostly use those days for programming, and I use it for my robots. So I have a robot like this, and I really wanted to add a camera to it. And CircuitPython has a support for cameras added into it, but it was only tested with one of the expressive demo boards called the Kaluga, which happens to have a camera plug on it. So it works with that, obviously, but there wasn't really any documentation or any easy way to get it to work with something else. So I decided to make a basically camera shield for this is the Wemos or Lolin S2 Mini board. So this is ESP32 S2 with the real USB. So it runs CircuitPython with the USB disk and everything. So it's convenient to work. And it has 2 rows of pins. So the external ones are compatible with D1 Mini, those very popular ESP8266 modules. And the internal ones are extra pins you can use. So I use those inside pins for the camera because it requires a lot of pins because it uses a parallel interface for transmitting the data. And as I said, it took me almost a year to actually get this shield working. Turns out that not all capacitors that are on the in the data sheets are actually not needed. Sometimes you have to put some of them back into the schematic. And it uses 3 different voltages for the sensor, and this one actually uses an external crystal for the camera clock. That's another thing I had to do. The original CircuitPython drivers assumed that you always are going to use a PWM pin to provide the clock for the camera. And I had to make a pull request to make it possible to use an external crystal, because that leaves that robot of mine that I wanted to use it with. It has 8 servos, and the S2 can use 8 PWM channels at once. So I would be one PWM short for the servos if I had to feed the camera clock from PWM, basically. So I have a version of this shield with the external crystal now. And yeah, I can do a quick demo. Share screen. Let's see how this works. Okay. So I'm going to connect this to CircuitPython.local, which is the MDNS name for this port. And all right, it should be video. Media. Go ahead and work whenever you are ready. Okay, let me do it again. Yeah, the god of live demos doesn't like me today. The problem is that the board has to connect to my Wi-Fi. Connection refused. Let's try one more time, and yeah, okay, no live demo, sorry. Anyways, so the nice thing is I got it to work with streaming, because this camera can do JPEG, stream of JPEG images, basically encoded in hardware on the camera itself. So it's quite easy to get that and basically push that into a WebSocket. And I modified the HTTP server on the CircuitPython to do that in background using async. So basically, the end effect of that is that if you are using async for other things you are doing on, for instance, this robot or on any other board you are using, you can do that while streaming the video. So you can blink at your LEDs, you can move the legs of the robot at the same time while the video is streaming, which is kind of a requirement in case of that robot. So once I got this working, I also have a version of that robot with the Raspberry Pi Pico microcontroller on it. And CircuitPython also has a slightly different library for cameras for the Pico, using the PIO pins to do the streaming. So I made a similar shield for the Pico with basically the same electronics. I have an SD card socket in here that is not populated because I'm still waiting for the parts. But otherwise, it's basically the same thing. And I added a button in front so you can do take photos easily, basically, and save them to SD card with the Pico. And it also works with the PiCo, the Pico W thing with the streaming. So yeah, that's basically what I've been working on. There is also in CircuitPython a library that lets you read QR codes using this camera. So it's a nice way of, I don't know, configuring your robot to just show it a QR code on the screen of the new configuration, for instance. You could do that. And I'm sure there will be more things. Now, Adafruit has introduced their own breakout for a camera that you can use with Adafruit boards. So I'm sure there will only be more image related libraries in there. Yeah, that's what I have. Any questions? I don't see anything in the chat. So yeah, I have a quiz prepared for us. So let's proceed to the quiz. I have to warn you that the quiz is malicious. It's I basically selected the questions I've heard people answer wrong on the internet, and I collected them here. And I'm sure a lot of people will have different opinions as to what the answers should be.
Okay, well, we'll see what we do.
However, I'm running this show now, so
Yeah.
You get to call the shots. Okay, let's see how we do.
Okay, I'm going to share it. Okay, can you see it? I guess.
Ooh.
Should we just answer?
So I think we should just write down your answers. We will go through it, and then we will go through it a second time, and then we can,
I need to have it ready so I can show it that I actually.
There is only 7 questions, so.
Oh, okay. I'm gonna write 1, 2, 3, 4, 5, 6, 7. It's like grade school all over again.
Yeah.
Okay, I'm good.
Okay.
Me too.
Clem, ready? Okay.
Okay, I say A, PHP.
I was saying A as well. I was thinking PHP. And the answer
is B, Python.
Oh,
by
really?
5 years.
Okay, now give us the dates.
Yeah, I was going to say, now I want the dates.
Python is 1990, and PHP is 95, and JavaScript is also 95. Yeah,
I had no idea that Python is that old.
I had no idea JavaScript was that old.
Yeah, JavaScript had its second year, basically, at some point where people realized that Java applets don't really work.
Oh, God.
The thing that I think throws people off with questions like that is, when was it actually invented, and when was it adopted by the mainstream? When are people aware of it? I'm not sure many people wrote in Python in 1990.
Yes. Also, Python 1. Something was terrible.
Yeah.
So.
I mean, JavaScript wasn't great back then either, and I'm not saying it's great now, but
it changed surprisingly little. Okay, let's see the second one.
So I'm 0 for 1.
Yeah, the C programming language is A, interpreted, B, strongly typed, C, memory safe. Pick one.
There's only one in that one because I know part of it is very wrong. So there's only one of them that's left. But then again, I spent a lot of time programming in C, so if I'm wrong, it's really bad.
Okay.
Okay, let's see what you've got.
Okay, I'm a programming noob, but I say it's B.
It's C.
It's A.
It's interpreted?
Why is C interpreted?
There exists.
It's compiled language.
Oh no. So okay, I'm going to join the internet crowd and go, hold it.
Right, it's for sure it's not strongly typed because it does implicit conversions.
No, and I didn't think it was memory safe, but I'm going, it's not an interpreted language, though I can understand that you could have C as an interpreted language.
If you have an interpreter, then it's interpreted.
That means every language other than bytecode is an
Yes.
interpreted language. Is that what you're saying?
That's why the distinction between interpreted and compiled languages is completely useless.
Okay. See,
Oh.
I always
Sorry.
I thought that
said
was
it's-
the only use case for is it interpreted or is it compiled to distinguish those
Yeah.
two. But
So,
Yeah.
See, what Giuseppo's really getting is he's getting into the nitty gritty because what he's
The
saying
thing
is
yeah,
the
it's
language is
runtime
not-
it's runtime interpreted versus build time interpreted. Compiled
yeah,
language.
that's the
So-
difference.
Yeah.
The difference
Compiled.
is not in language; it's in the runtime you are using.
Yeah. So
The language
okay.
itself is agnostic to that.
Yeah. Wow.
Yeah, but then also assembly is interpreted because it's not bare machine.
Yeah,
code.
exactly.
It is.
Yeah.
It's
Okay.
on x86. It is interpreted for sure.
Yeah. So unless you get all the
Right.
way down to actually I can't think of any. I've never programmed in bytecode. I've never actually programmed bytes into a computer before. So I can't
It's
say that
super fun.
Ooh,
I
Then I have one up because I have done a Hello World program on an Altair.
Oh wow. That's
Like it's a replica thing, but I've
Yeah.
entered the ones and zeros. So that was bytecode.
Oh, hold it. That
And
means everybody who did the 2022 SuperCon Hackaday badge
Yes.
has programmed in bytecode,
Yes.
which I
Yes.
did not do. So okay.
You can
So,
get
yeah.
those PDP-11 emulators for Arduino.
Well,
for
see, even when I
instance.
did PDP-11, it was still in assembly language. I never did bytecode.
But you actually have like those switches in there, arrow switches that let you input your program byte by byte.
Okay,
setting
I'm
the
0 for
bits.
2. Let's move on. I'm 0 for 2.
Yeah, me too.
Yeah, sorry.
It's an
going to
evil
be
quiz.
harsh. Sorry.
Okay. What's number
Question
3?
3. Which anniversary does open source have this year? 25th, 50th, or 100th?
I thought I knew, but now every guess I'm making is wrong, so I don't know. Okay, I'm gonna go with my first choice, but I don't think it's the right one. But we'll go with it anyways.
Yeah. Okay. Ready?
Okay, do we have our choices?
I have mine.
Okay, I say it's C because I
Okay.
think you are pulling a sneaky one, and I think the definition of open source goes back to public domain, copyrights, declarations. So I think you're referring to that one.
I'm going with A, which is the other end of the extreme, but I'm pretty sure I'm wrong.
A is correct.
Holy
The term
crap!
open source was actually published it's interesting. Open source is younger than Python.
That is really open.
That is pretty funny.
It's really interesting.
Like that.
Okay,
So
I got
how
number
did
one.
you?
Was
So
invented-
what is the date that you're setting for the beginning of open source? So what did happen?
There was a conference organized by Tim O'Reilly for the express purpose of telling the businesses that there is all this free code they could use, and it would be awesome if they started using it. Eric Raymond, Guido van Rossum, all those people were invited to this conference. And originally they proposed the name for it was completely different, but one of the people, I don't remember off the top of my head who exactly, you can find it on Wikipedia, proposed open source, and everybody liked this term so much. Before that date, of course, there was open source software. Software was always open source, like from the beginning when Ada Lovelace was writing open source software, but it was always open. But it didn't have the name, and there wasn't this
Okay, so your
movement.
sneaky one is that you're actually referring to the exact name open source,
Yes.
not the concept of free software.
Yeah. See, the only reason why I guessed A is because I saw
It's a very controversial quiz.
I saw something recently, and I think it might have even been on Twitter, saying it was, the 25th anniversary. And I'm thinking, but that was I was thinking it was like the 25th anniversary of the conference or something. And so when I saw it, I went, I'm just going to throw this out there. I'll go with A.
It was a conference.
Yeah, that's what I thought.
Mhm.
Okay, next one. Question 4. To use USB Type-C plug as USB 2.0, you need A. One common pull-down on both CC lines. B. Two separate pull-downs on CC1 and CC2. C. Two separate pull-ups on CC1 and CC2.
Okay, I know my answer already.
Yeah, I have my answer as well.
So
C.
Because I have a cheat sheet there on here.
yeah, the correct answer is B, of course.
Yeah, it's B. Yeah.
I
finally
put it
have
here
one right.
because I always get it wrong. So, and the Raspberry Pi Foundation also got it wrong.
Yes,
once,
and
so.
they're not the only ones. There are recent boards that also have it wrong.
Yeah, it's all right. The thing is it's, and I've got some people that are saying, I'm an idiot, but that's common knowledge. I've got a reel of USB micros, and so it's going to be a while before I switch to USB-C connectors on my designs.
Yeah, I wanted them right away. I've designed one board with USB micro, and I gave it to the client, and they tried it out once and ripped off the port. And then I switched to USB-C.
It's funny because I have yet to rip one of these things off, and I've been working a lot with them. But yeah, I can understand that. My problem with USB-C is A, the complexity of wiring it correctly and all the rest of that stuff. But the other one is the insertion force. If you have to use through holes on the legs, because the insertion force and extraction force on a USB-C is so high that you'll rip it right off the board if you don't.
Yeah, I'm also on team. You have to have legs on there. Like all of mine have legs.
Yeah.
But there are people, and I'm gonna name names, and I say Cyber City Circuits, Make Augusta on Twitter, who is a really big proponent of you don't have to, you just have to write USB-Cs and footprints, and you can make it as strong as with through hole parts. And I disagree. I don't think so.
So for me, with micro USB, I do this.
Yeah,
which
is a lot
of the plug
cleverer than normal USB.
If there is no socket.
Yeah. The problem I have with doing that is the fact that, like for my challenge coin, I go the other direction. I tried using a 1.6 millimeter thick PCB for the challenge coin in 2021. But in 2020, I originally went with a 2 millimeter thick PCB, and I've gone back to 2 millimeter. It just feels nicer for that particular project. But yes, oddly specific. I'm drawing a blank on Joel's handle on Twitter and stuff. He does the same thing where on his sensor watch design, the connector is the printed circuit board itself. It's kind of cool.
Mm-hmm.
Yeah.
Okay, next one.
We haven't seen a USB-C one yet, right? We have only seen that for USB micro and A.
Which?
Use the PCB as the connector.
No,
I have USB-C ones.
Yeah, and that's what. And
you have USB-C ones?
Yeah.
Do you have a KiCad footprint for that?
I don't use KiCad.
I believe oddly specific objects, which is Joel. And I'll try to get the information. Actually, the Sensor Watch project, which I believe is completely open source. It was also a crowdfunded or crowd supply project. He does USB-C. He does it using the printed circuit board itself.
I think he uses micro USB actually.
He does use.
Smaller.
I thought it had all those extra tabs across it. I'll have to double check.
But you can do both. Actually, for USB-C, it's better to use 0.8 millimeter board.
Yeah,
because it sits more.
It's supposed to be like 0.785 or something technically for the spec or something. But yeah, 0.6.
But it works, it's nicer actually than micro USB because it has those slots on the sides that click into the socket, so it's even nicer this way.
Yeah, I would use that trick if I could, but I can't. So
yeah, question 5.
Yeah,
I2C clock stretching is initiated A, by the master on the bus, B, by any of the peripherals on the bus, or C, either by the master or by the peripherals?
I'm
I
clueless.
say B.
I'm clueless.
I
'cause
say B, and I have absolutely no idea because I don't know what clock stretching is.
I
Okay.
would have assumed clock stretching would be done by a peripheral, but
That's correct. B is correct. And clock stretching, because in I2C,
Luck of the dumb.
in I2C, the clock is generated by the master, of course.
yeah, one of the
But,
cool things for people programming with SAMD21 is you can get away with doing USB without a crystal on the SAMD21 and probably the
yes,
SAMD25.
because it's just PLL.
What it'll do is it'll actually synchronize its internal clock based on what's coming over the serial line from the attached device.
Yeah. So in
or
case
on the
of,
USB device. Sorry. Yeah.
In case of I2C, the master decides how fast the clock is going to go.
Yeah.
And if the peripheral can't keep up, it has an option. It can hold, because it's open drawing lines. So when the master releases the clock line, it should normally go up because it's pulled up. But if the peripheral is holding it down, the master has to pause and wait for the clock line to actually go up. After, and that's called clock stretching. And some sensors even use it for like asynchronous communication. They hold the line down until they have a reading, so you can read the reading as soon as they are ready.
Before you jump to the next, I was going to say, before you jump to the next question, somebody made a really good comment in the thing, and I chuckled at it only because I posted a tweet the other day, which is, we've gone full circle. It's like the old double-sided floppy disks.
Yes. And because they said an evil USB-C where it connects to a different thing. I've used that, and I have it somewhere over there. I have made a robot that uses a compute module 4 on there, and an ESP32. So basically, real time is done by the ESP, and the CM4 does the high-level stuff. Yeah. And depending on which orientation you plug in the USB-C, you connect to either one or the other for programming.
Yeah, I have a funny feeling my desktop computer suffers from that problem, because the USB-C port on the front of my computer is almost useless. It's like 90% of my cables don't work with it because it doesn't seem to behave correctly. However, if I plug a USB-C to USB-A dongle into it and then plug everything into that, it works great. So I don't know what's going on, but I think it might be that whole issue with some PC manufacturers have done USB-C by putting two USB ports onto the connector, one on the top and one
I
on the
don't
bottom.
think they have the CC lines connected or something.
Yeah.
But,
okay, let's go 2 more questions. Yeah. Question 6. What is the main element, as in chemical element, in glass, the kind of glass you have in your window, or you drink from?
Got it.
A, carbon. B, silicon. C, oxygen.
I know what I want to say, but something tells me if this is a trick question, I'm going to be wrong.
Yeah.
Well, it's not a shame to be wrong.
I always thought it was sand, which is a silica, I believe.
Yeah, but it's silicon dioxide, so it's
that's what I'm thinking. So it's got to be.
There's more oxide than silicon in there.
That's what I was. I figured there had to be some sort of a trick. So it's what? Oxygen. It's the
every
part of it?
solid substance we have around us is probably crystalline with some oxygen in it, and usually you get more oxygen than the other element in there. So a lot of stuff around us is mostly oxygen. It's fun.
I knew I was going to be wrong, but that's cool. I learned something today.
So and it's SeO2. So 2 more atoms of oxygen than silicon.
Yeah, sneaky one.
Okay.
But the other one,
the other thing is you are like asking for the main element in glass.
Yeah,
you didn't specify more of. So,
Yeah.
and the other thing is more of in terms of the number of
In this
atoms,
case,
or is
it's
it the
both.
mass of the atoms, or
In
is
this
it?
case, both mass and number is
Yeah.
for oxygen.
Yeah.
But it's also if there is no silicon in them, then you only have oxygen. But if you don't have oxygen, you still have silica. So, yeah,
But it's not
right.
glass. It's not glass.
But it's not glass. Yeah, it's just powder.
Next one.
Last one.
Which of the following names is not a name of a text editor?
That's
A,
easy.
Ed, B, VI, C, Emacs.
A.
Okay.
Ed.
I want to have a whole separate conversation on who's a VI user versus who's an Emacs user.
Nano till I die.
So the answer is B.
Where's B? Oh, because
VI.
VI is not strictly a text editor.
No, VI is a command that runs editor
That's
named
Vim.
X.
It's hold it, Deshepa. What's the definition of VI?
No, VI is a command that runs a text editor named X in visual mode.
Oh.
Come on.
The editor is named X.
So Ed is a real editor?
Ed is a real editor. It was before before X. Basically, X is an improved version of Ed.
Another sneaky one.
Well, that's all right. I cut my teeth on Emacs, so.
Right, yeah. And Emacs, of course, has a VI mode in there.
So that's just bad.
Does anybody know how to exit that?
What? VI or Emacs?
Yeah.
I always have to Google that. I can never
Control Q something.
Well, you just close the window.
Yeah.
Anyways, that's all I have. Thank you.
There was a comment parent have said. Actually, I still use SED and awk.
Yeah, SED is basically a version of Ed that's for editing files inline, like without external input. But the commands are the same as in Ed. And in VI, in Vim, when you have X mode, those are also the same commands as in X. That's why it's called X mode.
There you go.
The colon thing where you type commands. So that was basically Ed. That was basically Ed. It was used on teletype machines without a display. So you wanted it to type as little as possible.
Okay, so
I should use that on my teletype.
You have a teletype? I've been shopping around for one. I don't know.
I don't not just only have a teletype. I have one that I equipped with USB.
Well, that's what I was going to do. I was going to hook it up to. I was going to make it at least serial UART. But no, I have very strange memories of using teletype.
Yeah, I've used it for two videos. One is like exploring how this thing works, and the other one is making a USB interface for it. And I now have it on top of a rack with an RC2014 beneath it and a Tektronix monitor, like a really old one from a huge oscilloscope.
Go ahead.
And I plan to make the teletype the input and output for that RC2014, so a C80 based computer. And the monitor should basically put out the graphics mode. So I also have to make a graphics card for that.
Yeah.
And since we talked about that bytecode thing, I think I'm gonna add in a panel with like a lot of switches so you can add bytecode into it. just for shits and giggles.
Yeah. Does yours have a tape reader writer on it?
Yes. Tape reader writer. I have a full reel of tape. And I've like in the video I've shown how to read tape in, and it basically prints a rickroll.
Oh God!
That's what I use the tape for.
Is it? But the type is 5-bit, right? 5 bits.
It's 5-bit Bordeaux code. Yeah. So it's more similar to Morse code than to ASCII.
Yeah. And does yours have the cylindrical print head on it?
No, it's a typewriter. It's like
Okay.
tick, 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 tick,
Okay.
with,
The one that we
high and
yeah,
low character,
yeah,
high and low characters. That's
Yeah.
it.
The one we had did the whole high low character and it had the paper tape on it, but it had the tall cylinder for the print head, if I recall correctly.
Yeah, that's like the Selectric type.
Well, yeah,
writing.
the Selectric had what we euphemistically refer to as bouncing Betty, the ball. This was just a
Right.
tall
Yeah.
cylinder. But yeah, we had that for ship to shore communication. Messages would come in on it and go out on that.
Oh, so yours is basically a newer one, like 70s, something like that?
I used it. This is going to date me now. I used it in, the late 70s is when I used it. And it was a relatively new machine at that point.
Yeah, man, it's from 61. So that's quite a bit older then. Yeah. So
Yeah,
that's
we
the
are
thing we
finished.
did. So thanks everybody for joining in and hearing our ramblings. And we would like to see you again on the Makercast. I would think so.
Hopefully in 1 month, the first Sunday of the month. We will see who will be hosting, but I'm sure there will be someone.
There we go.
So,
yeah.
If you want to get notifications, you can click on subscribe on this channel, or you can subscribe to the mailing list. I think there is a link in the description of the video. If not, I will add it later. And thank you, everybody. And that's it. Thank you.
Thank you for hosting.
Goodbye. Thanks.